I think the advantage we had, we weren't trying to invent something that was going to kill the world. We were trying to solve a problem for Phillips 66. And I would say the thing that Andy and I did, we made some very serendipitous decisions, but we fought IBM lawyers to keep it open. Keeping it open was probably harder than inventing it.
Hello and welcome to Unplugged, an IoT podcast where we delve into the fascinating world of industrial Internet of Things and automation. I'm your host, Phil Seboa.
Hey, Phil. Hello, everyone. And I'm Ed Fuentes. To be honest with you, Phil, I'm quite excited about today. We have a very, very special guest that I was telling my wife about him as well, that he's one of the co-inventors of MQTT, and I told her those little flashy three little digits, or little dots she sees when she's messaging. That's all MQTT. And to be honest with you, it's a very great honour to have the special guest, Arlen Nipper, with us today. He's the president and the CTO at Cirrus. And as we mentioned, he's the co-inventor of MQTT, which is probably the leading protocol for IoT and for IIoT. So we're quite excited, Phil.
Absolutely. With over 40 years in SCADA and IoT industry, Arlen has been pioneering the industrial automation and digital transformation space. We're really thrilled to have him share his journey and insights for us today. Arlen, can you take us back a little bit to the beginning, I guess? This is kind of really exciting stuff. I mean, yeah, look.
Well, sure. Well, Phil, Ed, thank you very much. I'm looking forward to this. It's an honor to be on the podcast with you guys. And I know from how long I've known you guys that you are really entrenched and interested in the projects that you do. I know the customers love what you do. And it's just really an honor to get to talk to you about it. So, people ask me about the backstory, and you're right. I came out of Oklahoma State. Actually, that's the town I'm living in. I'm back where I started. But in 1979, I had done a 2-year job co-op with Amoco Oil Company. That was before BP acquired Amoco. And I had a little bit of knowledge of digital electronics and things like that. And my first job was Coke Oil Company. And at Coke, they were building a pipeline from a facility in northern Oklahoma all the way to Houston, Texas. So I got to do everything from run the ditch witch to set centrifugal pumps, to learn how to run 480 volts to Toshiba vacuum tube starters. This is 1981, so Modicon had just come out with their Modicon 484 PLC. And remember, 1978 was when Modbus was invented, and so now we actually had a protocol that ran on the PLC, and then got to program the PLC. I got to learn what a 4 to 20 milliamp transmitter was. I got to learn what a motor operated valve was. How do you hook them up? How do you control them? What's a PID loop? How do you control the pressure on your pipeline when you start it up? So we did all that, and then we came back through, we had to automate it, and we had a DEC PDP-11 computer in the facility.
Is this cutting edge technology then, Arlen? Was this like really cutting edge, or you?
This was 1981, 82, 83, and remember, our infrastructure in the United States for anything, oil and gas, water, wastewater, 600, 700, 800 miles of high pressure liquid propane pipeline system. So, working at Coke, I learned, I got to build tank automation systems, automated truck loading systems. So probably about in 89, I quit Coke, decided to go to work for a startup company where we designed embedded computers. And with what I had done at Coke, I realized that we still had a lot of legacy equipment that was even back in the early 70s. They weren't a well-known protocol. All of them were proprietary. So we started building protocol converters. So we could take all this legacy stuff that Amoco and Chevron and Exxon and all the pipeline companies have and convert it to a more modern protocol, which in this case was Modbus. So we made a very good business out of basically, it's the old Dr. Zeus Starbelly Sneetches is you have protocol A, now you want to go to protocol B, and now everybody wants to go from B to C, and then C to D, and then back to B, and it was just this vicious circle with all these protocols. So we had, at that point in time, we probably had 60-70% of all liquid pipelines in the United States that we were controlling their infrastructure for. And a very disruptive thing happened. Remember, let's go back. All of our infrastructure was AT&T 4-wire circuits. But now we're into the 90s. AT&T got deregulated. And when they got deregulated, all of that really nice, well-kept, inexpensive, heavily subsidized infrastructure started crumbling away. So all of the VSAT vendors stepped up. Gilat, GE SpaceNet, Scientific Atlanta, AT&T tried them. And guess what? Yet another proprietary, because all of the VSAT systems have proprietary protocols for backhaul to get the data from your remote site, from your PLC, from your RTU into the base station or the Earth station. And from the Earth station, we had to get it into our SCADA system again. So we went around, we developed all this software. So we've gone from 300 baud pole response to 1200 baud pole response to VSAT systems. And then finally in the late 90s, 1998, Phillips 66, who had been working with all this time to build their protocol converters, got a brand new VSAT system from AT&T, and it was based on this thing that nobody had heard about called TCP/IP.
Oh, okay.
Now remember, 1999, if you were in the industrial space in 1999 and you were not using DEC equipment and you were not using DECnet, you didn't get business because DEC owned that market. People don't realize, how substantial DEC was in the automation industry at that point in time. So now we had TCP/IP, and of course, just like people do today, we'll tunnel our protocols over TCP/IP, and that was slow. And every byte that you added to your overhead of your system cost you $20,000 to $50,000 a year overall. So here we have a TCP/IP based VSAT system, but it was damn slow. Pole, propagation delay, response. I had over 100 booster stations. It took over 15 minutes to poll around all of them to get all my pressures, to poll again, get all of my valve statuses. So the manager was Steve Koenig, and he said, hey, I've got a really good friend at Phillips 66 in IT, and IBM has this new thing called Enterprise Service Bus. And they use this thing called messaging middleware, and applications for IT can publish information, and other applications can subscribe to that, but they don't know who published it. And we got to thinking about it, and literally it was just kind of a combination of Steve and I talking about it. And then at the time, IBM were very interested in getting into the industrial space. So that's where I met Andy Stanford Clark. So we started with the big IBM MQ series, huge, $800,000 worth of software, corporate enterprise, and started with their messaging system, which was huge, but we smashed it and smashed it and smashed it and smashed it. We kept, got to work with Philips on some prototype systems. And ultimately, back and forth, and that's where MQTT came from. So the original spec 3.0, it took us about 8 months to get that working, and now we're up to 3.01. So there's only been one change since 1999, really. Everybody says, "Oh, guys, you must use UDP. We don't really understand TCP. You better use UDP." And we looked and we go, well, if we use UDP, we'd probably end up reinventing a really bad version of TCP. And then let's fast forward from 1999 to 2024. When we did this, when we developed MQTT, guys, there was no cloud. Nobody was talking about security. None of that existed. And it's serendipitous that we picked TCP, which now security, right? And because we decided to make a remote originated connection, that's now called zero trust security. And that's why everybody's using MQTT in the cloud side. It's really the only way you get zero trust security, because there's no ports open, when you're sending data to the cloud. So it was to solve, I think the advantage we had, we weren't trying to invent something that was going to kill the world. We were trying to solve a problem for Phillips 66. And I would say the thing that Andy and I did, we made some very serendipitous decisions, but we fought IBM lawyers to keep it open. Keeping it open was probably harder than inventing it.
And I guess that was kind of the start for IBM as well in that open race, because they have since developed a lot of open standards. And
right about that time, Phil, you're right. In fact, only a few years later, that we took Sparkplug to the Eclipse Software Foundation. Well, I was working a lot with IBM when the Eclipse Foundation was started. And that literally, the president of the Eclipse Foundation is a gentleman, Mike Milinkovich. He was an executive with IBM. IBM said, "Here, Mike, here's $800 million worth of software. Go start an open source company." And you're right, Phil. That's where Visual Age tools, that's where all of that IBM technology went. And then that gave us the ability to start the PAHO project, which is on Eclipse. And of course, everybody doing MQTT will go to the PAHO project to get started. And now we've got Sparkplug at the Eclipse Foundation as well.
So through that whole journey, Arlen, you mentioned that MQTT really, since 1999 to that's 25 years now, it stayed at version 3, maybe a small minor version through that time?
It's at 3.1.1. Yeah.
Okay. So, because you've seen it, Arlen. Like you just mentioned, that TCP/IP you chose it. It wasn't like the adopted standard. It's become more adopted. You said about cloud and huge enterprise, wide area network connectivity. The issue with cybersecurity. These are some really key milestones that have occurred throughout the evolution, I suppose, of the industrial automation landscape. You've seen this all, you've watched it happen, and yet MQTT still seems to fit in those architectures.
Yeah, there was quite a lull. I would say, we came out with it. Andy and I flew all over the world. I mean, it was a tough sell, guys. Because the only way for the first 10 years of MQTT's existence, if you wanted a commercial MQTT broker, it was MQ Series, and that was $800,000, give or take. So it really, I think where things started to really take off was about, I think it was 10 or 11 years ago. Facebook did that blog where they said, "Hey, we've got all these problems with Facebook Messenger. Oh, we went out there, we found this thing called MQTT, and it solved all of our problems." And then Andy and I got PAHO up, and then we took MQTT through the OASIS standards body. And then Raspberry Pis started coming out, and kids started, and they had MQTT on them. And that's the beauty of MQTT, is that it's so simple that college kids and everybody can actually get it to work. I mean, imagine, everybody's going, well, it exploded. Well, it did, because how in the world, if I'm in college, if I wanted to play with even turning on an LED, can I download Allen Bradley protocol? How would I get my hands on? Where do you start? So look at our industry, OPC. Man, there's no way some college kid's going to get started with that. So, after 25 years, like you said, Ed, nobody shot a hole in it. It seems to work. It's well tested. It kind of was a flip cycle, because we invented it for OT, and then it sat there and kind of languished. And then IT picked it up, started using the hell out of it. And now with inductive automation and with all of this upsurge of IIoT, now it's coming back into its own in the OT space.
Yeah, but both Phil and I, we hear about MQTT. Phil, if you don't talk about MQTT every day, I'd be surprised. It just seems to be, in everyone's lips. It's it definitely, it's on the conversation. It's mentioned a lot. One query and side note here: the MQ and MQTT. You mentioned before that IBM had, what do you call it? A series MQ? What?
No, MQ series. So originally, MQ series was message queuing series, and that was all of that technology that IBM had built around message queuing technology. So MQTT, and we had we had SDIT, SCADA device. We had some crazy acronyms for it. It finally ended up being MQ telemetry transport, but after the Oasis Foundation, we kind of went through it. It's just, it doesn't stand for anything. It's just MQTT.
Okay.
So,
we just know it's a telemetry transportation.
Yeah, message queuing transport, MQTT.
Absolutely. I guess you make the point of it becoming available to the market, right? I mean, that's how I first came across MQTT, was because, it was starting to get adopted. It got huge, I guess, traction, not just in, people looking to expand industrial applications, but that IT sector started taking it on commercially. It became viable for home automation systems. The open source community started leveraging it in their projects, from Raspberry Pis to Arduinos to ESP32s, everyone taking it on as part of their, backbone of their learning capabilities. And that's something that I've taken on very, very quickly. I guess, what impacts has MQTT made that you didn't really kind of foresee coming?
I didn't foresee. I mean, you can imagine. I mean, Andy and I would laugh about, we're going to put a big broker in the cloud. We literally had said this to each other, is we were going to put a big broker in the cloud, and we would publish things. And like Andy would publish mousetrap statuses, and he lives in the Isle of Wight in the UK, so he was publishing the status of the ferry going between Southampton and the Isle of Wight. He was publishing all kinds of stuff within IBM. Then it almost went like underground. So today I hear about it, and we, back of the napkin, there's probably at any point in time, there's probably 8 to 14 billion MQTT connections just doing stuff. And like I said, Andy and I, you look at it, it's simple. You can publish anything you want on it. So you can mold, I'm sure that the way that we use MQTT in Ignition with Sparkplug, Doesn't look anything similar to how Facebook uses it to send messages. Doesn't look anything similar on how Amazon uses it to turn your lights on with Alexa. So that was the nice thing. Then it has state if you know how to use it. But the nice thing is if you don't understand state, you don't need a stateful system, it still works quite fine. So I think it was flexible enough. It was, we didn't dictate anything. We didn't dictate a topic. We didn't dictate a payload. It was super simple. The original spec was 18 pages long, and knock yourself out.
It's the things you mentioned there around where it's being used, just boggles my mind when I think about billions of devices. I remember 5-10 years ago when people were talking about IoT and IoT, the predictions of how many devices will be connected into this monolith, I suppose, of a connected world, and I just see MQTT becoming close to the standard protocol that people are adopting in that space. Has there been any let's say, I suppose, applications that really surprised you, like you knocked you out? I thought, how are they doing this? Has there been anything that really has caused you to laugh?
Well, a lot of them, I'm just surprised when I hear about them. I know many, many years in a row I went to the IoT World in San Jose, and I would walk around booths, and people were doing, crazy stuff. And I talked to them and go, "Oh yeah, we're using MQTT. We're a lot, so many products. We're using it in the background." And then here the other day, I saw a whole forum, and they're all over these bamboo 3D printers, and they use MQTT. And so it doesn't surprise me anymore, other than the fact that I just, they go, there's another application that uses it. I'm surprised at how many of the car manufacturers use it for their telemetry back from the car back in. It seems to be almost the de facto standard for that as well.
We're seeing digital transformation is a big topic. I mean, it's hot. Lots of customers are talking about it. Phil and I are talking about it every day, trying to discuss and understand. And how do you see MQTT fit into that discussion? What's the best way for people to understand how MQTT fits into digital transformation?
Well, again, we've had this really nice sidebar conversation about MQTT. That's fine, but the world we're living in, I know that one of the questions you guys were talking about is, how have I seen industrial automation evolve? And I would kind of put that back to you guys and say, well, it has evolved, but yet it hasn't, right? The story I just told you about Coke in 1980, other than it being slow, other than it being deck equipment, that could have been the same story that I told you that I did yesterday, right? So the challenge that we've got is we've got 50, 60 years of legacy infrastructure, legacy devices, legacy protocols, and we're talking about trying to corral the data that we do have. That's really digital transformation, right? We want to go into a factory and, we're not going to rip out infrastructure. We're not going to rip out all the PLCs. We're going to try to give you tools so that you can go in there and make sense of that information. So that's what we all do with Ignition, right? We try to use the tools within Ignition to get that data, to give it context. That's really my big thing for the last 4 years in my life is that, remember I told you the story that I learned what a 4 to 20 milliamp transmitter is. I learned what a motor operated valve is. Now that I know that, I could talk to you and Phil and go, hey, what did you set the URV and the LRV for your 4 to 20 milliamp transmitter? And that would be gobbledygook to everybody that doesn't understand what upper range value and lower range value. But with digital transformation, we can call that upper range value of a temperature transmitter and get that contextual data into the enterprise where now people can start actually using their data and understanding it. So I think a lot of the challenge that we have as automation engineers is to make automation humanly understandable. There's no reason for it to be so cryptic anymore.
Absolutely. You know, they say data is the new oil, right? But you know, you have to dig it out of those systems. The data is there. The data is there in most cases. We've been collecting it historically for decades. Some people even not pruning their data, right? And it's been sitting there in a data lake that they've been collecting it, but they just don't have the context around that data. They can feed it to an AI platform, but it doesn't have all the context around it to start understanding and pushing out value from that data. And that's where, I see MQTT as adding that context layer, adding that metadata, that small amount of data that's just going to create a better picture for the AI models of the future the now to be able to actually give value straight away as well.
Well, and I think that's a large part of what we've done with Sparkplug. I mean, Sparkplug has really started to take off, just like MQTT, in that, I was challenged. You think about it, that all of that work that we did for Phillips 66 and myself and an engineer by the name of John Lujan wrote all of that original MQTT, our topic namespace and our payload, and we developed that. And, we came from the good old world of assembly programming and C programming, and everything was very cryptic and binary. And so I was very scared in that first step in Sparkplug because we didn't want to lose the efficiency of what we were doing with old raw, binary MQTT, but yet we had to give it some discipline. MQTT was starting to go off, especially for industry. We knew we weren't going to make any progress unless we had a standard so that everybody could participate within the same MQTT infrastructure. So when and that was the other kind of key moment is that when Chris and I started Cirrus Link, we bootstrapped the company by doing oil and gas training for IBM, ironically. And we were in Calgary, Canada, and I was giving a seminar, and we had Plains Midstream come up and go, Arlen, we need to do exactly what Phillips 66 did. And so they were using Aviva Oasis DNA software, and we were trying to figure out how we could get visibility into this. And that's where I learned about a company called Inductive Automation. So I flew out. I met with Travis, and we wrote all over the whiteboard when they were, and came back and basically developed MQTT engine to actually look at the first thing that we did with Ignition is we just wrote a really simple MQTT adapter to it so that we could see these messages coming into Plains Midstream SCADA system, and it just kind of grew from there. So once we became a strategic partner, we started going to all the shows, and were meeting people like Benson at Opto 22, and he goes, "Oh, we do MQTT," and then the guy Eddie and the guys at Moxa, and we do MQTT, and then the IO Logic, we do MQTT. But the problem was if you took all of those and put them together, nothing would work. So that's where, like I said, I was concerned about it, but we sat down, basically tried to take so Sparkplug is like all the lessons learned of me and my team over the last 25 years, kind of consolidated down to say, if you want to do MQTT, you want to do real time, you want to do mission critical, this is probably a good place to start for all those projects that we had done that we go, oh, you know what? I sure wish we would have put a nomenclature right at the first to give us the version number. We didn't do that. And now we had, all of Phillips, we didn't have a little placeholder like Sparkplug B. So there was no way for us to go to the next version without being very difficult. And all of the other lessons learned is really what Sparkplug is.
Look, I'm so glad you said that, Arlen, because one thing that I know Phil and I would talk about MQTT, and it's like we have to educate customers or people on what is the Sparkplug B benefit. They hear of MQTT and not too sure where. We talk about Sparkplug B, and I'm really glad you sort of put into words and what it does, because I think that's the is evolution the right word? of having
it really is.
Of having a framework that everyone can adopt and use, and that does that. Like Phil was talking about before, giving data context. There's no better way than using the Sparkplug B, because now you can have multiple devices feeding into the same topic, helping to deliver context, and it's not much of a lift. From a technology point of view, the protocol's built, TCP/IP lives, and we've got all the infrastructure in there. And MQTT, the Sparkplug B, definitely is something that it does provide that context, that formality to a degree, or a standard, as you mentioned, to adopt, and it makes life easier.
Well, and we are migrating. I know in the outline that we were talking about, how have I seen it evolve in oil and gas and things like that. But you have to realize, let's put a marker in. We're 11 years that we've been working with inductive automation. And in that first 3 years, if you would have done a pie chart of our customer base, you're right. It would have been 95% oil and gas. As of today, oil and gas is less than 30% of our business. It's still growing, but all of the other sectors, food and pharmaceutical, logistics, manufacturing, wind, energy, all of those. So right now we're at approximately 4,000 different customers are using MQTT in just about every industry sector you can think of. And now our challenge is kind of this next step, and where I see things going is we're doing everything right on-prem. We've got Ignition, we've got all the tools, we're getting more and more equipment to talk Sparkplug. Now people are wanting to go to the cloud, and really that's where things are starting to get, either easy or hard, depending on how you look at it. Right now, I've been talking with Walker Reynolds. I've been talking with a lot of folks, and we think that Snowflake is emerging as a really kind of a emerging next technology. Not so much that Snowflake's doing anything; they are doing something special, but I think what happened, remember 11 years ago, I can still remember driving around in a car all over Oklahoma, Texas, wherever, talking to all my old customers after we had started Cirrus Link, going, hey, Dale Johnson was the head of Phillips 66 SCADA. Are you guys going to move to the cloud over our dead bodies? Never. Oh, Arlen, look at our server room. Look at all of the servers that we've got. That was 10 years ago. So I'm thinking 5-6 years ago, people started going, well, we need to start moving to the cloud. Well, they got stuck right there. They go, oh, well, we have to take care of S3 buckets, and we have to take care of Kinesis streams and Lambdas and AWS Glue or Microsoft ADX. The problem is that now they're playing down here in the plumbing, when really they should just be using the cloud, and that's what Snowflake does. So and now, if I can take a Sparkplug message and it hits Snowflake and it's immediately available as an object in SQL as a model, then I've just eliminated 90% of the lift to do something with it. And then, like you said, Phil, now you're looking at putting an LLM on top of that, or whatever else you want to do with it. But we can't lose sight of the fact that, going back to the three principles that Don Pearson and myself over the last 10 years is, what do you want to do with digital transformation? You want, number one, you want to decouple. You don't want to hard code your equipment to one application. You want to decouple it. Number two, you want to provide a single source of truth. Number three is I want a better, faster, more secure, more available operational on-prem system, first and foremost. And people keep forgetting that. And it's almost like they want to just jump over anything secure and good on-prem and just go straight to the cloud. And I think that is a huge mistake, because now, you are not going to control anything real time from the cloud. It's just, you're not going to do it.
And it seems like, IT seem to like that, safe space in their cloud infrastructure, but don't quite understand what is needed from that OT layer, to keep that real-time information, to keep critical infrastructure running. And it seems like this hybrid approach is more likely the direction that most manufacturers and food and bev companies and pharmaceuticals and all these industries that really have, are aiming for 24/7 operations with lower downtime within that space. And yes, their example of that is, the cloud offers 99% uptime, but what happens in that 1% or the disconnection from that?
You could decide to, take your plant down, the cloud goes down, but, I don't know where we're going to go. I just know any way you look at it, I hate creating data swamps. And we have customers that are creating data swamps all over the place with, terabytes of data. And you go, what are you doing with it? We don't know. Why are you putting the data in there? Oh, because corporate.
It was a trend. You go to conferences, put the data in the cloud.
Yeah. No, we are quite adamant. I work a lot with Poogle, John McCarran at Snowflake, and we're doing quite well with customers, with Snowflake. But I like the Snowflake approach is that, look, until you find a business case, well, let's not put a bunch of data in Snowflake. And, if you're not going to do anything with it, then don't put it there in the first place.
This data governance and data strategy, needs to be at the forefront of any project that you're trying to move forward before you invest, huge amounts of money in trying to get the data there.
Well, and I saw that, I see that emerging. We started 4 years ago, this whole notion, I hate the word, but I'll say it, is this notion of a digital twin. And I think the reason I hated the notion of a digital twin is I saw who created it. Amazon created a digital twin. Well, hang on. That's not the way my digital twin, I look at it. I don't think it should look like that. And then AWS, they came out with, Microsoft came out with Azure digital twin. And, I'm looking at that one and go, that's not it either. So the thing I like that we did is that the digital twin, when you create those with Snowflake, that is literally an Ignition UDT. So that is a digital twin the way that you, Phil, want your digital twin. And oh, by the way, you can change it, right? Somebody else didn't invent it for you and say, well, Phil, this is your digital twin. And you can have a Boolean or a float or an integer, and that's all you get. And, it's not going to know where it came from. So you're so constrained within that. So I do like, I think digital twins are going to be important, but I think we've got to be able to create those. It's just like, how many people are actually using models from the OPC UA companion specification? Zero, right? And why? I was on the board of directors for the Heart Communications Foundation. I played in all of the field bus wars. I've been in all of those standards bodies. And I'm here to tell you that if you create a standard, nobody will follow it. So give the customer the ability to create information the way that he wants to see it and the way it's valuable to his enterprise.
Yeah. I mean, these standards, are usually dictated by, I guess, people not implementing them usually, right?
Exactly.
So, I mean, a framework is much more useful in that space to be able to, have that leverage. Yes, have a standard in terms of the way that you're moving the data upwards and the structure around it, but that modeling space is very bespoke to the customer and very bespoke to how they want to interpret that data, even the conception of that data as well. So it's very interesting to see how that's starting to progress. Everyone is pushing for a standard, but doesn't really have the answer around what should that look like into the future. And
I mean, you have to be careful. You might get what you have to be very careful because you'll get what you wanted or what you wished, and it won't be what you wanted. Because if I was going to come up with the standard for a centrifugal pump, and it's got suction pressure, case pressure, discharge pressure, I've got my RPM, I've got my and then somebody would say, oh, well, what about this? And you're going to add this, and what about this? And you're going to add that, and then what you've ended up is you've created a pink elephant and nobody will use it. And even if you took the best centrifugal pump model in the world that Chevron were using, if you took it over to Exxon, they're going to look at it and go, oh, that's not the way that we do it. So, exactly.
Arlen, look, I've been hearing you for many years, and I love your passion. I love your drive. Where does it come from?
My wife asked that, and I said, one of these days I'm going to write a book and explain what I do. Because, people ask my wife, what does your husband do? He goes, I don't know. He plays with computers. To me, I told you I'm back at Oklahoma State. I was going to be an electrical engineer. My dad was a farmer, but before that, he had been an engineer for NASA, for the Apollo program. And, I worked on the farm and, combines and tractors, and I enjoyed it, but, you had to make a living. Second year, man, I was ready to get out of here. And, I was going to go quit and do something. I went to my professor, and on the way, I saw there was a posting for a job co-op at Amoco. And this was in 78, 79. So I go to Tulsa, Oklahoma, and they go, well, Arlen, we've got this new lab. It's called the Microprocessor Development Lab. And that summer, and I still remember the engineer, Joe Hammond, Mike Vitale, and they helped me, and RCA had just come out with the first CMOS 1802 processor. It ran at like 400 kilohertz. And I got to wire wrap it up and then write machine language, burn it into an EEPROM, plug the EEPROM into the circuit board. We had an 8-digit display, and we were doing downhole gauges. And ever since that, I came back to Oklahoma State. I knew exactly what I wanted to do, and I've just enjoyed it ever since. It just kind of clicked in my head. The kind of the notion of software and hardware had always just kind of clicked in my head, and I've always enjoyed it. And so as long as I get to keep playing with Opto 22 and Raspberry Pis, I'll still be getting up at 6 o'clock in the morning and doing this.
You are continually learning. I'm sure you are. Phil and I, we're learning as well. We're trying to learn the journey. So what are some of the things that you're next looking forward to learning that maybe we should also look into learning as well? What are you striving for learning other things?
Well, again, you're right. To me, like the snowflake was a big learning curve because, ask Arlen how much SQL he knows, and it's about this much. But since it worked so well, now I'm quite interested in learning SQL. And you could look at that and go, well, Arlen, everybody knows SQL. No, my background has been, PLCs and, writing code has not been in databases, but I'm starting to understand that really the power in, if we're going to do AI, predictive maintenance, all that, the power, the common tool out there is SQL, and it's all the tools that go on top of that. So for me, I keep learning as far as just, network technology, security technology, hardware technology. But for me, the big learning curve here lately has been learning Snowflake. And I think my prediction is Snowflake's not going to be unique. There's going to be a whole bunch of other platform virtualization companies that come along that are going to sit on top of the cloud infrastructure. So again, Amazon, Microsoft, Google, they do great stuff. But if you're playing down in the guts of, I got to spin up a virtual machine and then I've got to set up my network infrastructure to do this, then, hang on, step back. Is that really what you should be doing? Or should you let Snowflake do all of that for you and you get to work on your data and do something interesting?
Okay. Making a note of that one.
We're absolutely, I guess, myself and Ed are, as he mentioned, on this learning journey. So we're definitely taking, all these real bullet points of things that we need to learn as well, really to heart. And this is something that we're really passionate about, is sharing that journey with our listeners as well. So, we really thank you for taking the time to really talk through this, your incredible journey and insights into industrial automation. It's really something special.
Well, thank you very much. I've enjoyed it. And like Ed said, what else would I do if I didn't do this? It would be, it is an interesting profession. I mean, there's very few that you're going to get up and, man, there's going to be something today that we're all going to have to learn. And there's really no other, I say that, I'm sure there is mechanical engineering and chemical engineering and all that. But when you look at what we do with ignition and with all of this every day, now I know that when you manufacture glass, that melted glass is poured onto liquid mercury to keep it smooth. Now, 2 months ago, I didn't know that. I thought, well, that's pretty cool. So every day you get to talk with customers and learn, what else is new out there.
There's so much to learn. And like I mentioned earlier on the podcast, I could listen to you for hours and hours and hours. It's a real honor and pleasure to have you here. We're both in Australia, so let us know when you're down in Australia soon, because it'd be great. It'd be really great to meet you.
Well, and as you know, Ed and Phil, I did spend probably 20 years ago, I spent a lot of time in Australia because I did a lot of the TAB slot machine automation. So love it. Spent a ton of time in Sydney and got lost one day running over this, when you run over, I was in North Sydney and you run over the bridge, and I was running around the Opera House and came back up onto the bridge. But if you come up on the wrong side, you can't get across the highway to get back over to the hotel. So I ended up finally having to take a cab to go around to get back to my hotel.
I think we've all got lost in the realms of Sydney, especially going over the bridge the wrong way and all sorts.
But Phil, I do have a picture I did when they would let you. So I've got my picture on top of the bridge in the jumpsuit tied to the. So I did the bridge walk.
Okay, yeah,
so
that's pretty famous.
Cool. Yeah.
Oh, that's fantastic.
Yeah.
Well, once again, thanks again. And for all our listeners, please, I highly recommend you do follow Arlen Nipper and Cirrus Link on whatever platforms you want. But that's the best way to stay up to date with what Arlen's doing and learning. He does post quite a bit, and he's quite in that space, excellent sharing any knowledge. So thanks again, Arlen, for your time. Really appreciate it.
Well, I appreciate the time. I enjoyed it, guys.
Don't forget to subscribe to the Unplugged and IoT podcast, and you can find that on all your regular platforms.